Okay, let's talk about sound for a few minutes. So sound, we've talked about it already, but it's a form of energy that causes the molecules of a medium to vibrate back and forth. Okay? And it's made of a series of compressions and rarefaction. It's a longitudinal or compressional wave. You can see there's a zone of compression and a zone of rarefaction, and the movement of the wave is from left to right. Okay? And it compresses the air molecules. And it also has areas where they're rarefied. Okay? If there are no molecules or medium, then there's no sound. Okay, typically the speed of sound in air on Earth is 340 meters per second. But speed does increase as temperature increases because the molecules of air are moving faster. Okay? Sound is transmitted faster in solids than liquids because solids are more elastic. Okay? And again, you can we talked about this before, but sound is a longitudinal wave or a compressional wave. So it's like a slinky where you push it. Okay, you push it and you get areas of compression, which correspond to the crest, and we're higher energy, and areas of rarefaction, which correspond to the troughs, and this is the wavelength, lambda. All right? Intensity of sound is measured in a unit called a decibel, and you can see what some typical intensities of sound are for some different cases. Okay? So let's talk about frequency and pitch. Okay? Pitch is a common name, basically used a lot in music, and pitch is just another way of saying frequency of a sound. Okay? So pitch depends on how fast the molecules of medium vibrate, okay, which depends on the frequency of the wave. So pitch is like frequency, all right? So a high pitch has a high frequency. A low pitch has a low frequency, all right? And again, we've talked about this, but 1 hertz, it's a unit, and that unit is cycles per second. It's one hertz is equal to 1 cycle of a wave in 1 second of time. Okay? The human ear can hear a range of 20 hertz to 20,000 hertz. And you can notice a dog can hear even a larger range, for example. Okay? Okay, let's do some practice here really fast, right? Okay? So the pitch and frequency can change if the speed of sound changes. Okay? So why, I'm not going to spend a lot of time on this, but why when you hail helium does your voice sound higher? Okay? Well, pitch is frequency. Okay? Well, helium is less dense. Okay? And that affects the speed of the wave, the sound, and the speed would be 2 to 3 times faster. And because it's faster, since velocity equals frequency times the wavelength, then the velocity is faster, then the wavelength has to be faster. And it turns out that because the wavelength changes, that you hear only the higher tones, all right? Practice number 6. A car passes you while honking its horn. What do you notice about the sound? Well, as the car approaches you, okay, you hear higher pitch. That's called the Doppler effect. We'll talk about that more later. And you hear increasing higher pitch or frequency, right? And increasing loudness or amplitude. Okay? Okay, so as something moves toward you, it has a higher greater, actually I'll say this differently, has a higher amplitude, but it's really a more compression. Okay? More than amplitude. It's equivalent to amplitude. Okay? As it goes away from you, it will have lower pitch and decreasing loudness. All right? So practice 7. What describes what is occurring to the amplitude and apparent frequency as the car continues to move away? Well, as the car moves away, you hear a lower pitch. And that means a lower frequency. And you hear decreasing loudness. Okay. Okay. And less compression of the sound. Okay. Practice 8. A child pushes a swing. What's the frequency on the swing if she counts 25 complete swings in 200 seconds? So that's 25 cycles. It's asking for frequency, right? 25 cycles in 200 seconds. Well, I want frequency in hertz, and that's the number of cycles in a second. So I divide 25 by 200, and what do I get? 0.125 cycles per second, or 0.125 hertz. Okay? Okay, I'm not going to talk too much about the quality of sound. You can read this, okay? And we'll come back, okay? Okay, timbre, quality of the sound, okay? And then resonance. Okay, take a read through that. All right.